Okay, in this video, we're going to go over some possible procedures and strategies on how to solve systems of equations by translating real life situations into equations, and then equations maybe back into real life situations. Think of, again, math as a language where you can translate and describe the real world and actually make some really interesting predictions and solve some interesting problems in a way that, let's say, textual languages can't do. Now, whenever I'm translating real world into math, I have really kind of some certain things that I do. I just wanted to go over them with you. So if I see a text in front of me, I always try to underline what key information I can. And that key information really has to do with the quantities, mostly quantities that are described in the text, right? There's some things that textual language, like English and Spanish, do that math doesn't. Like, textual language can describe things with like adjectives and running quickly and that sort of thing, and math doesn't handle that. But it does handle things that are like quantities, like things that are numbers and shapes and sizes and and rates, that sort of thing. So I look for those type of words. I try to make a sketch if I can, to describe what those shapes might be. I also try to identify what variables and numbers that are in the text, so I'm just underlining those things. Like, for example, X would be the number of trees. So I'd say number of trees, and I would just underline it and just give it the variable X, since I'm looking for the number of trees, okay? Then I translate those variables and numbers into equations. And if I can, I look for things that I know that are in equations, like I need operations like pluses and minuses, and a greater than means increasing, and is means equal, that sort of thing. So I look for that and try to arrange those numbers and variables into equation sentences. Then I start solving those. I just use all the things I know about math in terms of solving, and I solve those equations. Then I go back to the situation itself, and I see, does the numbers that I've come up with, the solutions that I've come up with, right, do they answer the question being asked, and do those solutions make sense? Okay, so again, underline quantities and shapes and sizes, that sort of thing. Sketch if I can. Try to put numbers and variables into equal to some like kinds of descriptions. Then I translate them into equations by using the operations and the equations, solve, and then go back and see if what I've solved makes sense. That's real, just kind of the basic things that I do. Now let's practice one of those, okay? Here's an example. Now, according to my situation, the Green family has a rectangular garden with a 20-foot perimeter. They want to enlarge their garden to be twice as long and 3 feet wider. This new enlarged garden would then have a perimeter of 42 feet. Answer these questions. What are the dimensions of the original garden, and how much new area did they add to their space? Okay, now let's go back to, again, what my procedure was. I'm looking for quantities, I'm looking for shapes, I'm looking for sizes, that sort of thing. So I'm going to underline these key terms. Rectangular garden, 20-foot perimeter, okay? They want to enlarge, so I'm making it bigger, to be twice as long, 3 feet wider. The new enlarged garden now has a perimeter of 42 feet, and I'm looking for the dimensions and how much new area was added. Now, again, going back to my suggestions about how to do this, right? I'm going to try to sketch this as much as possible. So I know that I've got a rectangular garden. So I know some things about rectangles, right? I know that they are equal on two sides. So there we go. Here's my original garden. And I also know that a perimeter is just adding up all the sides, right? So I'm going to call this side the length, and this side therefore has to be the exact same length. This side is W, so this side over here has to be a W. And when I add all those together, W plus L, W plus L. My original garden has 20-foot perimeter. So let me just translate this, okay? I can actually say 2 times W, because there's the same, plus 2 times L, right, is equal to 20 feet. So there's a perfectly good equation, right? There's my operations, there's my equal sign, and I know that because of the word perimeter, and it just kind of lets me go forward and translate those variables and numbers into an equation. Now let's keep on going. They want to enlarge their garden, so I'm just going to make a slightly larger garden. Okay. Now, what do I know about this new enlarged garden? It's twice as long, so not just L, it's 2L. Right? So again, this up here has to be 2L as well. I also know that it's 3 feet wider, so now it's W, but plus 3, right? And this is also W plus 3. Now, I've actually sketched and written out into numbers everything that I've underlined, right? I can do something more with this down here, right? Just as the same way that I was able to add all those sides together to equal 20, I can add all these sides together to equal 40. So I'm going to say 2 times the width, in this case W plus L, or plus 33 rather, plus 2 times this plus this, or just 2L rather, 2 times 2L's, will be equal to 42 feet, okay, which is my new perimeter. Now, here's a bit of an issue. I've got 2 variables in each of these equations, and you can't solve, by itself, you can't solve an equation that has 2 variables in it. I do have some techniques in math. I could actually just maybe go ahead and draw this on a XY graph. I can just say these are my X's, these are my Y's, and then I can, every point along the way would be like a combination of X's and Y's, or I can use what's called simultaneous equations or systems of equations. Put these 2 together and then use some of those techniques in order to solve it. Now let me show you what that means. I would just say system. I can use a system of 2 equations to solve equations that have 2 variables in it. Now, let me show you how that works. I'm going to actually just do a little bit of work over here first and write it out into a simplest form. So I know that 2 times W plus L is actually just 2W plus 6. I'm just going to distribute the 2, right? Distribute this 2 and I get 4L. That's equal to 42. I'm going to put the numbers on one side, the variables on the other. So I'm going to subtract 6 from both sides. I'm going to have 2W plus 4L is equal, minus 6 here would actually be, what, 36. Okay. And now I'm going to take my 2 equations that I have, okay, this one here, and this one here, and I'm going to put them into a system of equations and solve for them. All right. Now let's do that. So I've got 2W. Whoops. Let me just move this up a little bit so I have some extra room. 2W plus 2L is equal to 20. And down here I've got 2W plus 4L is equal to 36. Okay? Now, one of the techniques I have in solving systems of equations is what they call elimination. And I can just graph these actually on a Desmos, for example, and I could just see where they intersect. Where they intersect would be the answer for the L and the W. But I could also just do this by hand, and this system is called the elimination method. Now, in the elimination method, I just want to get rid of one of these variables. And the way I can do that is to line them up, like it is here, W on W, L on L, numbers on numbers, and then add them or subtract them so that one of them disappears. I can subtract these. 2W minus 2W is just 0, so these just kind of like eliminate. 2L minus 4L is a negative 2L. 20 minus 36 is negative 16. I'm going to divide both sides by a negative 2, and I'm going to get L is equal to a positive 8, because negative divided by negative is positive. Okay? Now, I can go back to the original equation, so let me just go back to 2W plus 2L equals 20, and just plug in the 8 into the L, right? Because I just solved for L. And let's see if we can find out what the W ends up being. All right, so I'll call this my step 4. 2W plus 2 times 8 is 20. Keep giving me space. 2W plus 16 is 20. Step 7. 2W, let's subtract 16 from both sides. I get W is equal to 2. Now, let's remember one of the steps I said in the procedure is to take these two numbers, plug them back in, and see if it makes sense. 2 plus 2 is 4, plus 8 is 16. 16 and 4 is 20, so it actually makes sense. But that has to make sense in this one too, because L's and W's are the same. 2 plus 3 is 5. 2 plus 3 is 5. 5 and 5 is equal to 10. 2 times L is 8 is 16. 16 plus 16 is 32. That adds to 42. Yep, sure enough it does. Makes sense. Okay, so again, just follow the procedure that I talked about, right? Identify the key terms, and again, you're looking for key terms means you're looking for shapes, quantities, sizes, rates, that sort of thing. You underline those. Translate them, all right, into mathematical symbols, variables, for example. Once you've actually changed them to variables, change those into equations by looking for operations, like, adding, subtracting, that sort of thing in the words, keywords. You always try to find the equal sign because that's part of an equation. Then put them into some kind of equation and solve them. Check and see if they make sense by plugging them back in and seeing if they answer the questions that you were asking. Now, what are the questions of the original the dimensions of the original garden? It was the width was, what did we say, 2 feet. The length was 8. How much new area was added? I forgot to do that part. Remember that area is length times width, so it's 2 times the width times the length. 16 square feet, right? And the area of the new place, right? Let me see, this we said was 5 by 16. So 5 times 16 is equal to what, 80 square feet. Subtract the 2 and I get 64 square feet. 64 square feet was added to my original dimensions. And look at the perimeter didn't really increase by all that much. Isn't that interesting? Okay, I hope this was helpful to you.